Welcome to the session 4, Unit 4 of our financial modeling course. In this session, we are simply going to consider the model evaluation, that is, evaluation of the models, and also the issue of model specification as to how important it is for us to get the correct model or specify the correct model. By the end of this session, we should be able to explain the relevance of model evaluation in empirical analysis. Model evaluation. Correct specification of a model is an important premise of the classical linear regression model for empirical analysis. But also, the search for correct model can be difficult despite the fruitless academic or professional endeavor. It doesn't matter how good you are or how experienced you are in terms of the academics. You could sometimes find it difficult to get the correct model or specify the correct model. So in practice, we mostly use empirical works or work that has been done in previous studies or previous works that have been published in the field in order to get or specify the correct model. And also there's a need for us to get the best available data, because we said that the quality of the data is as important as the final result that we are going to obtain. So we have to use the best model or possible method of estimation. Now we should be able to specify the best or the very best model, and we don't have to just come out with models that we have to be we have to choose the best model, or we have to come out with the best model that is based on empirical studies or based on previous studies. Building a robust empirical model is an iterative one. Thus, model building is an art rather than a definite science. So it is quite changing. There is the issue of dynamism or it is quite dynamic. There is the issue of changes in terms of model building. So it is not something that is quite robust or quite stringent. There are some flexibilities in the building of model. So factors such as change or resistance, that is the inertia idea or the issue, specification error, the car web phenomenon such as supply reaction to prices, and also how time play factor or play the role that time plays the in decision making. And also we can come across the issue of data manipulation, that is how differencing of our data will have impact on our model. And also there is the issue of non-stationarity, where the mean, variance, covariance among the other factors or among all the properties of data come to play. And also the issue of autocorrelation. So a financial econometric model tries to capture the main features of an economic phenomenon, taking into account the underlying economic theory, the prior empirical work, intuition, and research skills. In the first session, that is in the unit 1, we made it clear that in building a model, there are some steps that you have to pass through, and one of the things, or the most important thing, is that you can't build a model out of intuition. You have to make the model building depends on an economic or a financial theory, and then you have to look at empirical works, and also the relevance or the other issue has to do with the issue of data. You also have to gather the best available data, and the data should be of the good quality so that you don't have to face the issue of garbage in, garbage out. So we will specify our model in table 3.13, and we'll see how this will fare in the face of autocorrelation. So this was the issue of total deposit, where we said it is depending on the annually adjusted inflation, the petroleum price, the treasury bill, and the we are now adding the auto regression or the autoregressive nature of the TDP itself as an explanatory variable, and see how it will fare. So equation 3.34 is autoregressive, where we have the last term to be the lag of the regression. So this same regression, we have its lag being the last term of the explanatory variable. So we want to find out if the past total deposit plays a role in determining current total deposit. So we want to see how this influence the total deposit. So how the lag of the total deposit itself play a key role in determining the value of the total deposit. So that will show here we are looking at the change of the resistance issue, where we earlier spoke about the inertia and how it factor into the issue of autocorrelation. We will display our estimation in the next table, that's table 3.19, and we are going to estimate, we are going to check as to how this play a role in the presence of autocorrelation. So we are going to consider how the table or how our result will fare in the face of autocorrelation. Table 3.19 is the autoregressive model of total deposit. So here we have model we have estimated our model, and the upper part will definitely deal with the descriptive. So where we have the dependent being the total deposit, and the method is least squares. This is the sample that we used, and also the number of observation was 242 observation after a series of adjustment. So as usual, we have our constant, we have our annually adjusted inflation value, the coefficient is there, the standard error, we have our PP, which is the petroleum price, we have the treasury bill rate, we have the lags of the total deposit also playing a key role here. So we are going to consider, so here we have coefficients. Constant is always ignored. We will look at the annually adjusted inflation. We will see that the coefficient is less than the standard error, and our t statistics is less than 2, which makes it insignificant together with the probability value of 0.6. Also, the petroleum price has a coefficient of 1.50. The standard error is still 5.4, which is higher than the coefficient. We have a t statistic of still less than 2, and our probability value is higher than 0.05, which shows that it is still insignificant. Our treasury bill rate following the same suit, and the lag value rather seems to be significant because we have a coefficient of 0.9, we have a standard error of 0.02, which is less than the coefficient. Our t statistic of 36.2 is way ahead or far ahead or higher than the 2 level or the 2.0 standard that we have set for ourselves, and our probability value of 0.00 indicate that the lag value of the total deposit simply plays a key role in explaining the movement in the value. So here we are saying we can attest to the fact that there is an issue of autocorrelation. So it's like the lags value can explain the values of, or the movement in the values, or the movement in the dependent variable. So we can also, with the issue of autocorrelation, we have to resort to the use of the David-Watson test, and the value close to 2 indicate that there is the issue of autocorrelation. So we can clearly see from the table that the lag total deposit is highly significant, and it affects carry total deposit when we hold that as in constant. This could be due to inertia, which is the issue of change of resistance. The question now is, do we still have autocorrelation in the risk specifier model? Our first point of call will have to be with the David-Watson, as we earlier said, just as per the illustration of the same. So we remember that with the David-Watson test, the issue, it cannot cover the issue of lag values. So we resort to the modified David-Watson test, which is a standard value on a standard normal distributed of the David-Watson test. So here we can clearly see that the David-Watson cannot capture the issue of autocorrelation in terms of lag, or with respect to lag values. So here we will consider the issue of we will consider the test of autocorrelation by the Bruce-Godfrey ILM test, which could accurately deals with the issue of lag, or which deals with lag values. Unlike the David-Watson test, which cannot cover or which cannot capture the issue of lag or autoregressive model, the Bruce-Godfrey Lagrange multiplier test, however, does work with this autoregressive model. So the report indicates strong evidence of no autocorrelation because both the f and chi-square statistics are low. This is this value. This is the f statistic, and this is the chi-square value. They are actually low with p-values of above 0.05. We set a p-value that is a significance value or level of 5%, and this the p-value from the Bruce-Godfrey test was above the 5% that we set. So it makes it clear that we now fail to reject the hypothesis that there is no autocorrelation within the series. So at this stage, since we have achieved our autocorrelation, or we've achieved no serial correlation among the series or among the lag values, we end our iterative process. If you could clearly see that from the other results, it seems to be the same with the David-Watson test and the same thing applies here as we saw from our previous slide. So even in the Bruce-Godfrey test, we are still going to have values as we achieve in the test of the David-Watson test, but this is an additional test which will be able to prove the existence of autocorrelation otherwise in terms of lag values. So we have come to the conclusion of this session, and we'll continue with the next session, as the next session consider the issue of model specification, which is quite important in financial modeling. So in this session, we have explained the relevance of model evaluation in empirical analysis. We have been able to specify our model and tested for the presence of autocorrelation and come to the conclusion that there was no autocorrelation in the specified model. Thank you.